We're going to use a ratio test to determine whether the series is convergent or divergent. So with the ratio test, we have a series of this form, and then we take the limit as n approaches infinity of the absolute value of a sub n plus 1 over a sub n. We do this to find L. If L is greater than 1, this diverges. If L equals 1, it tells you nothing, and you must do another test. If L is less than 1, this absolutely converges, which implies that it also just converges. So a sub n plus 1 is just wherever we plug in n plus 1, wherever we find an n in our original a sub n. In the case of this particular problem, we probably want to rearrange this, because we know we're going to have something in a numerator and something in a denominator, and we want to make it easy on ourselves. So I would rearrange this. The numerator is the same, not going to change that. Here we notice that we can use some exponent properties. So this is negative 3 to the power of n times negative 3 to the negative 1. Negative 3 to the negative 1 is the same thing as bringing negative 3 into the numerator. We bring negative 3 into that numerator. And now we can notice that we have something to the power of n, and we have another thing to the power of n, namely pi in the numerator and negative 3 in the denominator. So we can bring that into its own thing. N equals 1, and we have pi over negative 3, and this is all to the power of n. And we can get rid of the negative because that cancels out with this one. We have n we have n times 3, which is 3n in the numerator. And if you notice what I did, this isn't being multiplied, this isn't being taken to the exponent of n, and this isn't being taken to the exponent of n, so we can leave that as that factor there. Now it looks a lot better, and we can plug in n plus 1 for all n's. Pi over 3 to the power of n plus 1 times 3 times n plus 1. Here's our original version, pi over 3 times n times 3n. This, again, by the exponent properties, is pi over 3 to the n times pi over 3 to the 1, which is just pi over 3. So this is the same thing as pi over 3 to the n times pi over 3 to the 1, which is just pi over 3. That means that these cancel out, and we're left with pi over 3, and we have these 3's canceling out, so we have n plus 1 over n. This is all being multiplied to each other. This is just a constant, so when we take the limit as n approaches infinity, what we care about is this side, which has the variable n. This is pi here. So now we can do this by dividing everything by n in the numerator, dividing everything by n in the denominator. Limit as n approaches infinity of the absolute value pi over 3. We could probably stop with the absolute value now, everything's positive. N over n plus 1 over n, n over n. N over n gives us 1. So we have 1 and we have 1. We plug infinity into that denominator under 1, and that gives us 0. We plugged infinity into the denominator, that gives us 0. So 1 over 1 is just 1. Pi over 3 multiplied by 1 is pi over 3. So we get pi over 3. Now we ask, is pi over 3 greater than 1, equal to 1, or less than 1? Well, it's greater than 1 because the numerator is greater than the denominator. So that means that this diverges. This diverges by the ratio test.